Hello everyone. So this is a question from JEE Mains 2026 8th April Shift 2. Which statements are true? Okay. Statement A. In Hoffmann bromamide degradation, 4 moles of NaOH and 2 moles of Br2 are consumed per mole of an amide. Okay, important. 4 moles of NaOH and 2 moles of Br2 are consumed per mole of an amide. Statement B. Hoffmann bromamide reaction is not given by alkyl amides. Okay, not given by alkyl amides. Statement C. Primary amines can be synthesized by Hoffmann bromamide degradation. Okay. And statement D. Secondary amide on reaction with Br2 and NaOH will give secondary amine. Okay. Statement E. The byproducts of Hoffmann degradation reaction are Na2CO3, NaBr, and H2O. Okay, so the chapters involved is amines. Whenever a primary amide, that is, R, C, double bond O, and H2, primary because, you can see this nitrogen is connected to only one carbon. So whenever we have a primary amide treated with an aqueous or ethanolic solution of sodium hydroxide, that is NaOH, and bromine, that is Br2, it gives a primary amine. Okay, it will give us a primary amine RNH2, which has one carbon atom less than the original amide. This is the amide that we started with, and we are getting an amine which contains one carbon less, because let's say here there was X, so here one carbon, so X total carbon is X plus 1. Here we have only X carbon. So we get a primary amine which has one carbon atom less than the original amide, and also there are certain side products which are formed. So along with the primary amine, we have Na2CO3 plus NaBr plus H2O. Okay. Upon balancing, this reaction becomes 4 NaOH and 2 NaBr and 2 H2O. So this is the complete balanced equation. This is a 1 degree amide and we get a 1 degree amine. Okay. So therefore statement A is false. Statement A says that in Hoffmann bromamide degradation, 4 moles of NaOH and 2 moles of Br2 are consumed per mole of an amide. Okay. It is false because 4 moles of NaOH, that is correct, and 1 mole of Br2 is consumed. In the statement A, they have mentioned 2 moles of Br2. No, it is 1 mole of Br2 per mole of an amide. For every 1 mole of amide, we need 4 moles of NaOH and 1 mole of Br2, as we can see from the balanced chemical equation. Okay, so therefore statement A is false. Then we have to talk about statement C. Statement C is primary amines can be synthesized by Hoffmann bromamide degradation. Yes, it is true, because 1 degree or primary amines only are synthesized by Hoffmann bromamide degradation. We will always get a primary amine. Okay, so therefore statement C is true, because 1 degree or primary amines only are synthesized by Hoffmann bromamide degradation. Then we have statement E. Statement E says that the byproducts of Hoffmann degradation are Na2CO3, NaBr, and H2O. So therefore statement E is true, because we can see from the balanced chemical equation, that is this one, that the byproducts are Na2CO3, that is sodium carbonate, NaBr, that is sodium bromide, and H2O, water. So therefore statement A is true. Okay. And regarding statement B and D, for them, we have to know the mechanism of Hoffmann bromamide degradation reaction. Okay, we have to know the mechanism. The step one of the mechanism is OH minus of the strong base, that is NaOH, attacks the amide gets deprotonated and water is formed. Okay, so step one is OH minus of strong base. So we have taken NaOH, attacks our amide. Amide is deprotonated and water is formed. Okay, so to show that, so let's say we have primary amide, RC double bond O, N with a lone pair, and H. Okay, and let's say we have a base OH minus. So this comes from the NaOH. So this guy, being a base, extracts a hydrogen, and nitrogen takes these electron pairs. Okay, so using arrows, so therefore we get, so since nitrogen extracted these sigma bonds as lone pair, so we will get RC double bond O, N lone pair H, and there will be a negative charge, and obviously H2O as one of the side product. Okay, so this is step 1. Step 2 is the anion that we formed, that is this anion, attacks bromine, that is Br2. Okay, so let's say this is our anion. So anion attacks Br2. Okay, so that is this guy, RC double bond O, N with an H, attacks Br2. Br2 is 1 2 3 4 5 6, 1 2 3 4 5 6. Okay, so this nitrogen can, using these lone pairs, attack one of this bromine, and this bromine can take this electron pair and go out to form a bromide ion. Okay, so using arrows I can write, I can show the electron transitions like this. So therefore we are left with RC double bond O, N H, and this nitrogen, since it has formed a bond with this bromine, so we will be having a new NBr bond, and obviously this guy will be existing as a bromide ion, that is Br 1 2 3 4 5 6 7 8 and negative charge. Okay, so this in general is known as N bromamide. Okay, and then we have step 3. In step 3, the N bromamide, this guy, is now attacked again by the base OH minus, leading to its deprotonation and formation of water. Okay, so this guy, that is RC double bond O, N with a lone pair, and H and Br 1 2 3 4 5 6, is attacked again by the base. The base will obviously extract NH, so it will give its lone pair here, and nitrogen will take these sigma electrons in the form of lone pairs. So we will be left with, you know, RC double bond O, N with two lone pairs again, and then Br and the negative charge with N and a water molecule. Okay, and this anion is known as bromamide anion. Okay, and in step 4, the bromamide anion undergoes rearrangement. R group, which is bonded with carbonyl carbon, this R group now bonds with the nitrogen instead. Okay, and simultaneously the bromide anion leaves, so this bromine goes out. Okay, so simultaneously this R undergoes a rearrangement. Now it is in bond with N, and this bromine takes these sigma electrons and goes out in the form of bromide ion. So using arrows, so R C double bond O, N Br, so this is our bromamide anion. So first, Pr takes these electron pairs and we get Rc double bond On with two lone pairs, and obviously Br has gone out in the form of a bromide ion, and this guy undergoes rearrangement. That is, R, which is currently, bonded to a carbonyl carbon, now bonds with the nitrogen instead. So using arrows. So therefore we get C double bond O N bonded with R. Okay, and nitrogen has two lone pairs and carbon has got a positive charge. Okay, and oxygen has two lone pairs. It can show resonance, and these lone pairs can form a pi bond, and ultimately we get O C N R. Okay, so these guys are known as alkyl isocyanate. Okay, in step 5 we treat the alkyl isocyanate with NaOH and we hydrolyze it. Okay, so we take the alkyl isocyanate and we do NaOH and hydrolysis, and we end up with RNH2, which is the primary amine, and Na2CO3, and the other byproducts. Okay, so this is very important. We'll see why. So therefore, regarding statement B and statement D, we need to know that if you have RC double bond O N and connected to two hydrogen, then this is known as a 1-degree amide, because obviously nitrogen is connected only one carbon. It is also known as a primary alkyl amide, 1 degree or primary alkyl amide, as nitrogen is attached to only one carbon. If we have RC double bond O N connected to H, but it is connected to one alkyl group, let's say it is CH3, then this guy is an example of second degree amide or secondary amide. It is also known as secondary alkyl amide, as nitrogen is attached to two carbon, and RC double bond O N connected to CH3 connected to another CH3 and lone pair. So this guy is an example of a tertiary amide. It is also known as tertiary alkyl amide, as you can see nitrogen is attached to three carbon, 1, 2, 3. Therefore, statement B, which says that Hoffmann bromide reaction is not given by alkyl amides, is false, because it mentions alkyl amides don't give Hoffmann bromide reaction, which is false because there are three categories of alkyl amides, which we just saw, right? This is the first category, that is 1-degree alkyl amide. This is the second category, that is the secondary alkyl amide. This is the third category, that is tertiary alkyl amide. So statement B says that none of them gives Hoffmann bromide reaction, which is not true, because the primary alkyl amides, that is these guys, RCONH2, these guys, they do give or show Hoffmann bromide reaction. Okay, because because N is connected to two hydrogens, so therefore they do show Hoffmann bromide reaction. So therefore statement B is false. And regarding statement D, which says that secondary amide on reaction with Br2 and NaOH will give secondary amide, is false, because secondary amide and tertiary amide, that is these two guys, they don't give Hoffmann bromide reaction. Very important. Okay, secondary amide and tertiary amide don't give Hoffmann bromamide reaction. Okay, because the mechanism requires nitrogen to have at least two hydrogen to react with base, that is OH minus and Br2, to form the intermediate, which is an isocyanate. Okay, so I will write this down. Mechanism requires nitrogen to have at least two hydrogen to react with the base, that is OH minus and Br2, to form the intermediate, that is isocyanate. Okay, so we saw in the mechanism we have two steps, step 1 and step 3. Okay, those are very important to us in the mechanism, step 1 and step 3. In step 1, can you see in step 1 the base is attacking a hydrogen, so therefore one hydrogen is required in the amide. Okay, and in step 3, can you see again a base OH minus is attacking a hydrogen which is required in the amide, right? So 2-degree and 3-degree amide, that is these guys, they have 1 and 0 hydrogen attached to N respectively. So therefore they cannot show this reaction, because according to the mechanism we need two hydrogens attached to nitrogen to which the OH minus can go and attack. Okay, and also one more thing is, can you see in secondary and tertiary amide there are bulky alkyl groups now? These bulky alkyl groups on secondary and tertiary amide block the site of attack. So therefore, this is one more reason why the reaction cannot happen. Okay, so therefore statement D says that secondary amide on reaction with Br2 and NaOH will give secondary amide. No, it won't. It won't undergo Hoffmann reaction at all. Okay, so therefore the question is asking us which of the following statements are true. So therefore only statement C and statement E are true statements. So A is false, B is also false, C is true, D is also false, E is true. Okay, thank you.